Hello friends, good morning. Today our topic is a diagnosable of matrix. So ये बहुत ही इम्पोर्टेंट टॉपिक्स है और ये इस टाइप्स के प्रॉब्लम एवरी टाइम गेट के एग्जामिनेशन में आते हैं फॉर गेट पर्पज एंड नेट पर्पज आल्सो. So let's watch here. To here I will some provide the technique and how to check matrix is diagnosable or not. So please here before go to the solutions notes. So please subscribe my channels, like, share and tell to friends for subscribe latest updates. So now go to the diagnosables of matrix. So first your question your minds कि how to check the matrix, how to check the matrix is diagnosable or not. Either first questions. First question, matrix is diagnosable or not. So suppose let matrix A is here, A11, A12 up to A1n, 21, 22 up to 2n up to nn, n1, n2 up to ann. This is n cross n be a square matrix order n cross n. N cross n, that is it. Consider this matrix order n cross n. So that case first we just find out the eigen's value. So require the characteristic equation. Characteristics equations. So one by first we write down the characteristic equation A minus lambda I equal to 0. So that is the A minus lambda I. It means matrix is given the first word find out the eigen's value. Means find out eigen's values and eigenvectors. That is important. Eigen's value and eigenvectors. So here is the A11 minus lambda, A12 up to A1n, A21, 22 minus lambda, 2n up to an1, an2 up to ann minus lambda. This is equal to 0. So here that is 0. So now let lambda 1, lambda 2, lambda 3 up to lambda n are n distinct eigen's values of matrix A. This is generally considered that lambda 1, lambda 2 is lambda n are n distinct eigen's value of matrix A, and x1, x2, x3 up to actions are eigenvector vectors corresponding eigen's values lambda 1, lambda 2 up to lambda n. So that is the basic information. Here is the first your matrix is given. तो पहला वर्क है कि अगर मैट्रिक्स गिवन है तो आप पहले फर्स्ट आइगन्स वैल्यू एंड आइगन वेक्टर फाइंड आउट्स करें. फिर नेक्स्ट अब गो टू द डायग्नोजेबल ऑफ मैट्रिक्स एंड सम थिंग्स. सो डायग्नोजेबल ऑफ मैट्रिक्स, तो ए एन क्रॉस एन. So now next diagnosable of matrix A. What is, how can say that? So suppose matrix is a n cross n matrix over the field F is said to be diagonalizable. Here it is, if it is similar to matrix D. Matrix D means diagonal matrix. That is what we similar है, as a matrix is similar but not diagonal. Every diagonal matrix is not a diagonalizable, but diagonalizable matrix is the diagonal matrix. So that is, remember, it means a diagonal here. In other words, a diagonal matrix, if there exists a non-singular matrix P, that is a non-singular matrix P here, such that invertible, yes, P, such that case P inverse AP, P inverse AP equal to D, P inverse AP equal to diagonalizable of this, the element of D. So element of D is here eigens value, that is here eigens value of A, that is, remember, element of D is the eigens value of A. So lambda 1, lambda 2 and lambda n. Otherwise P inverse AP, it can be written as this format. This is here P inverse AP, lambda 1 diagonal elements, and that is 0. So for your first work, find out the eigens value and eigens vector. After that is work. Next, some important points for diagonalizable matrix. So here first, for some important points, if matrix A is diagonalizable, here A is diagonalizable if and P is a non-singular matrix P, such that is a very important problem. AP equal to PD. AP equal to PD is here. P inverse AP equal to D. So that is here. So AP equal to PD. Next, if matrix n cross n matrix A has n distinct eigens value, then A is diagonal. मतलब eigens value अगर n eigen value different है, that case is matrix is also diagonalizable. If lambda 1 lambda 2 are n distinct roots, matrix so diagonalizable, और same words meanings है दोनों का. Next, if the x1 x2 x3 or xn n distinct, this is eigenvectors of corresponding eigens value, repeated or non-repeated, no problem, of a matrix, then x1 x2 are independent here, then matrix is diagonalizable. It means यदि आपको n eigen vectors find out कर लिया आपने, n क्रॉस n मैट्रिक्स है तो n eigen vectors हमें फाइंड आउट है और विच आर इंडिपेंडेंट है, दैट केस मैट्रिक्स इज डायगोनालाइजेबल. रूट्स आर रिपीटेड एंड नॉन रिपीटेड, नो प्रॉब्लम, डजंट मैटर्स. आइगन्स वेक्टर्स आर कॉरस्पॉन्डिंग टू डिस्टिंक्ट आइगन्स वैल्यू ऑफ A are linearly independent. So eigenvectors are corresponding distinct eigenvalue, means distinct, but distinct eigenvalue है, so eigenvectors are linearly independent. If number of eigenvalues is equal to number of eigenvectors in general, so independent, then matrix is diagonalizable. मतलब आप कभी फाइंड करिए, अगर आपको नंबर ऑफ आइगन्स वैल्यू और नंबर ऑफ आइगन वेक्टर्स आर इक्वल्स मिलते हैं, सो दैट केस मैट्रिक्स इज डायगोनालाइजेबल. नेसेसरी एंड सफिशिएंट कंडीशंस ऑफ मैट्रिक्स condition that n cross n matrix A over F. If F is diagonalizable, A has n linearly independent eigenvector. It means matrix अगर suppose diagonalizable है, that case we matrix have n linearly independent eigenvectors. So important point for repeated roots. Important point. So suppose 3 cross 3 matrix है, so let lambda 1 lambda 2 equal to m and lambda 3 be roots of above matrix. here. So it means two roots are repeated. Roots are repeated. So now, so here arise two cases. So first case first. So case first. Find eigenvalue for eigenvectors for lambda 1 equal to lambda 2 equal to m. Lambda 1 equal to lambda 1 equal to m. So suppose two repeated roots है, so something lambda. So case first, that case arise the first case first here. If find eigenvectors for lambda 1 lambda 2 equal to m. So suppose मान लो लेट कर लिया मैट्रिक्स इज ए माइनस लैम्डा इक्वल टू एक्स इज द मैट्रिक्स इक्वेशन इक्वल टू 0. So that case a minus mi is equal to 0. Suppose that case if rank of matrix is 2, that is a important rank of matrix is 2 हमने कंसिडर किया है, दैट इज कंसिडर. सो नंबर ऑफ फ्री वेरिएबल दैट केस क्या होगा 3 minus 2 मीन्स नंबर ऑफ रो माइनस number of rank means is the n minus r. So here so 3 minus 2 is 1. So that case we get only one eigenvalue, one free variable. It means we get the one eigenvectors here. So one eigenvectors for two roots, and we get the one eigenvectors for two roots lambda 1 lambda 2 m. Let the eigenvalue of x1 here, which is the only represent the x1 x2 x3 में से कौन सा फ्री, एक वेरिएबल फ्री होगा. सपोज x इज इक्वल टू x1 x2 x3, तो एनी वन इज फ्री. दैट इज हियर वन मीन्स हियर एनी वन इज फ्री when rank of matrix is 2. So but here only one eigenvectors for two roots, that is important here. दो रूट्स के लिए सिर्फ एक ही आइगन वेक्टर मिलता है. हियर एल समथिंग. सो लेट आइगन वेक्टर इज x1. सो सेकंड आइगन वेक्टर फॉर सेकंड डिफरेंट आइगन वैल्यू लैम्डा इक्वल टू 3 के लिए फाइंड आउट होगा. आइगन वेक्टर ऑफ लैम्डा इक्वल टू लैम्डा 3. सो a माइनस लैम्डा x इक्वल टू 0. सो दैट केस वी गेट द अनदर आइगन वेक्टर. सपोज दैट इज x2 and second eigenvectors. But conclusion here, what is the conclusion हमारी here से 3 eigenvalue, but we get only 2 eigenvectors. It means 3 eigenvalue के लिए सिर्फ हमें 2 ही eigenvectors मिल रहे हैं. That case we cannot find the non-singular matrix P. Non-singular matrix P find out नहीं कर सकते non-singular matrix P. So matrix A is not diagnosable. It means number of row is equal number of eigenvalue is not equal to number of eigenvectors, not equal. That case which is not diagnosable. Case first. Next go to the case 2 here. Suppose lambda 1 equal to lambda 2 equal to m, matrix equation that is here. So suppose that case rank of matrix is 1, means so number of free variable is 2, means that case we get 2 eigenvalue, means here is x1 x2 x3 here. So any 2 is free, any two is free. So that case this in case 2 eigenvectors x1 x2 मतलब here rank 1 है. So in that case 2 eigenvectors हमें find out होंगे. Suppose this is x1 and x2. And eigenvectors for lambda equal to 3. So suppose x3 is the third eigenvector. Here we get the 3 eigenvectors x1 x2 and x3. You can find the non-singular matrix P is here. So that is A is diagnosable. So important है कि अब repeated roots हो या non-repeated roots हो, first we find out the eigenvalue and eigenvectors. If eigenvalue and eigenvectors are equals, then matrix is diagnosable. And diagnosable matrix is the element of diagnosable matrix is the root eigenvalue. So elements always याद रखिए डायगोनालाइजेबल मैट्रिक्स का जो एलिमेंट्स होंगे वो क्या होंगे, आपके आइगन्स वैल्यू होते हैं। एलिमेंट्स ऑफ डायगोनालाइजेबल मैट्रिक्स have eigens value. That is important. Here is the eigens value. So another similar matrix A is said to be the similar matrix. A is said to be similar to B. There exists a non-singular matrix P such that B equal to P inverse AP. That is satisfied, then this matrix is similar. This is the transformation of A to B is known as similarity transformations. Otherwise, another similar matrix ABC, it is another's have same eigenvalue. It means eigenvalue यदि मैट्रिक्स के सेम है तो मैट्रिक्स इज सिमिलर इफ कैरेक्टरिस्टिक इक्वेशन ऑफ सिमिलर मैट्रिक्स आर सेम। मतलब कैरेक्टरिस्टिक इक्वेशन भी अगर दो मैट्रिक्स के सेम है दैट इज सिमिलर। नेक्स्ट पावर ऑफ मैट्रिक्स ए कैसे फाइंड, सपोज दैट इज फाइंड हाउ कैन फाइंड आउट द ए रेस टू एन। तो सिंपल दिस द ए रेस टू एन इज इक्वल टू पी d raised to n p raised to minus 1 where p is the non-singular matrix, singular matrix, and p is equal to x1 x2 up to xn. That is the eigenvectors corresponding to eigenvalues. Now taken problems. Some taken problem which check which of the following matrices are diagnosable or not. He is given matrix A and first matrix and second matrix is here. So first, so we get the go to the one by one. Matrix A is here. So A is equal to 2 1 0 and 0 1 minus 1 is 1. Can you see? तो फर्स्ट वर्क आपका फर्स्ट वर्क है पहले फाइंड आउट द आइगन वैल्यू एंड आइगन वेक्टर्स फाइंड आउट्स करें आप। इज हियर आइगन वैल्यू and eigenvector. So characteristic equation is write down, that is here characteristic equation. Solve this, then we get this 2 2 3 2 2 3. So now find the eigenvectors corresponding eigens value. That is here first step, here find the eigenvectors corresponding to eigens value. So eigenvector for this lambda 1 lambda 2 equal to 2. So matrix first we write down the matrix equation A minus lambda into x equal to 0. So here is put there and simplify this 2 minus something matrix A minus lambda I 0. This is A minus lambda. So we get this 0 here and simplify this here. So next that is replace is same. So we get this here 0 1 0 0 minus 1 something. So rank of this number of non-zero row 1 and 2, that is the number of non-zero row 1 and 2. So free variable is 1. So x2 equal to 0 here, that is multiply row by column x2 equal to 0, x2 plus x3 equal to 0, so x3 is 0. So let x1 equal to t, this is x1 vector x1, this is, so we get, but we get here only one eigenvectors, that is here one eigenvector for two eigenvalues. दो आइगन वैल्यूज के लिए सिर्फ एक ही आइगन वेक्टर फाइंड आउट हो रहा है हियर. तो फर्स्ट इज फाइंड आउट, सपोज इज x1 फाइंड आउट. नेक्स्ट आइगन वेक्टर फॉर लैम्डा इक्वल टू 3. तो लैम्डा इक्वल टू 3 के लिए अनदर आइगन वेक्टर फाइंड आउट होगा, सपोज अंदर ही इज x2 फाइंड आउट. बट conclusion here कि only x1 and x2 only two eigenvector find out here. So it is clear for three eigenvalues we get only two eigenvectors. So in that case p cannot find, p find out नहीं कर सकते. So that case matrix is not diagnosable. Here next go to the second problems. So let's be here problems given. So your work is find out the eigenvalue and eigenvector first. So my characteristic equations and solve this. We get solve, then we get 1 2 2. that is the roots is a 1 2 2. So find the eigenvectors of this for lambda 1 lambda 2 equal to 2. To matrix equations, here a minus lambda x equal to 0, that put this value to something lambda minus 2, so we get this here. So simplify, solve, we get which is solve, then we get this 1 minus 2 2, and here that is here first, here 0. So that case is rank of matrix, it is here simplifications matrix, and which is then for next solve this and we get this. So this is 0 0 and 0 0. So that case, what is the rank of matrix? Rank of matrix is 1. So what is rank of matrix? So that is the matrix, rank of matrix is 1 here, rank of matrix is 1. So that case free variables, number of free variable is 2. So equations x1 minus 2x2 minus 3x, in that case here x3 equal to t and x2 equal to alpha, 2 free variable. So that is 2 parametric constant including here t and alpha. X1 equal to t plus 2 alpha, x equal to x1 x2, put this value up. So this is 2t 2 alpha, 0t alpha and t. So separate using the matrix property and something separate t 2 0 and 1 2 1 0, that is here 2 0 2 0 1 2 0 1 and 2 1 0, that is here, suppose that is here which is x1 and which is x2, sorry 2 1 no? That is here 2 1 0, that is here x1 and which is x2. So we get any one आप consider कर सकते कोई भी. So now we get the eigenvectors, two eigenvectors, here two eigenvectors. Now for next eigenvector for lambda equal to 1, a minus lambda I equal to x equal to 0. So here simplify this, solve up. So now we get the third eigenvector, this is important. So here 3 eigens value, we get the 3 eigenvectors, 3 eigenvectors, 3 eigenvectors, 3 eigenvalue. The non-singular matrix P is here x1, x2 and x3. Is find out is here x1, x1, x2. So that case here P 2 1 0 0 2 0 1 and 3 minus 1 and 3. So how to check is the answer diagnosable or something? Verify this matrix diagnosable or not. So this is verify, that is very clear. So AP equal to PD, that is the conditions AP equal to PD. So that case is answer is correct. Verify. So D is what is the diagonal elements, 2 eigens or diagonal elements, and the only element of D, this is the eigens value 2 2 1. So AP is equal to this, here multiply and we get this 4 4 3 2 0 minus 1 and something, multiply this and we get PD, so P and D. So that is here AP equal to PD. Verify. So that is that type of problem solving by these methods. So first here work is find out the eigens value and eigenvector, check that both are equal, so that is a diagnosable and something. That time eigens value diagnosable matrix पे every time 2 or 1 problems आते हैं. So take cares and simplifications. Suppose here, so these are important notes here. See, if S be the diagnosable matrix है और उसमें अगर if T is a matrix of such that suppose S equal to S plus alpha T equal to I, alpha is a real, alpha belongs to R, so then T is diagnosable. मतलब identity matrix हो अगर sum of this, so that case is also diagnosable matrix. Thank you, and please subscribe my channels, like, share and tell to friends.